This week, we got some good bug fixes in that I want to tell you about. They're scattered all over our stack, and I've ordered this video kind of in terms of complexity. So there's chapter markers. You can jump to whatever bug you find the most interesting. If you're new here, we're building a note-taking app. It's called Lockbook. It's end-to-end encrypted, cross-platform, collaborative, and open source. So the first couple of things we're going to talk about are in our CLI. Addressing these should help a lot more people try Lockbook. Then we're going to move on to some front-end development. We want to tweak the aesthetics of our file tree on Linux and Windows. And then we're going to talk about what I'm most excited about, which is shipping a much better PDF experience to all our platforms. As a bonus, the various parts of Lockbook get deployed to a bunch of places all over the internet, and that's powered by some pretty interesting deployment and automation scripts. So we'll show you how Lockbook 25.11.11 was released to like the 20 places that we ship Lockbook to. So let's start off by talking about our CLI. The point of our CLI is to allow people to edit their notes using their own tools. Episode 3 dove into all the workflows our CLI supports, but for now, we'll just talk about the most basic one, editing a file in a foreign editor. Things will start moving pretty fast soon, so on the top left here, you'll always be able to see the file I'm editing, and on the right, you'll be able to see either the GitHub issue I'm trying to solve or the PR I'm working on. And if you want to dive deeper into this code, the diffs will be associated with either the issues or PRs. You won't have any trouble finding those on GitHub. I start things off here by adding to this list of enums for all the editors we support, and then I follow the compiler around, fixing all the problems I encounter. So the first place we get tripped up is on the actual command we need to execute. And so we need to pop open Helix, read the documentation, figure out how it wants us to handle this situation, and we can store our findings inside this match statement over here. Guided by our compiler, we go to a few other locations, like the list of completions for specifying an editor in the command itself using --editor, and then we test this. So we're using the editor and visual environment variables to detect this setting so that your favorite editor is already selected. And once we've confirmed that this is working reliably, off to the master branch it goes for a round of QA by the team. I also changed the way the Lockbook editor environment variable behaves. In the past, it used to be just an override that's specific to Lockbook for the editor environment variable, but instead it feels more useful for it to be a fully custom command that you can specify any editor, even ones we don't support. So that got the same treatment. This time I tested it out with Z, and once I felt confident in the implementation, this is also something that we released in 25.11.11. All right, now let's kick things up a notch. So we have a friend, they want to use Lockbook, but they've invested a significant amount of effort in the Bear note-taking app. I actually used to use Bear back in college, and so from my days of using it, I know we're going to run into a few problems. First of all, Bear uses a tagging system instead of a more traditional files and folders. And it was actually one of the reasons I stopped using Bear, because I was pretty sure Bear wouldn't last in my life forever, just on the fact that they don't have a Linux app alone. And I knew if I kept investing in Bear, at some point I would have to write code to get my notes out of Bear into something else. I started to put my notes in a portable format, so I didn't have to do that. And then a couple of years later, I find myself in the ironic situation of having to write code to get someone else's notes out of Bear into my app. I guess it was unavoidable ultimately. So anyways, I go to Bear, I create an export, and then I start poking around the data inside Lockbook to see how our image is formatted and, how are the tags structured. And right away, I run into my first bug within Lockbook itself. It seems like our CLI is particularly bad at dealing with spaces inside file names. So fixing this becomes the first order of business. We jump back to that same file we've been editing within the CLI and ensure that if someone passes in a quoted string or an escaped space, we handle that appropriately. And then we also make sure that if a file name has spaces, that in suggestions, it'll show up appropriately. That fix gets merged to master, and then we come back to creating our import tool. Okay, with that fixed, I can now open these documents in the CLI, and then the next thing I spot is that the image format looks a little strange. All of our images are pretty human readable, but it looks like these images have paths which are URL encoded. And so once again, we pause work on the import tool, and the next order of business is making sure that we handle URL encoded paths properly. I check some specs and I make sure that this is in our best interests before I just add it to the platform. Once I'm sure that this is something we actually want, I dive into the code that handles relative link resolution within the platform. I grabbed the URL in code crate. It's pretty small. I read through the whole implementation and it's very widely used. So I feel comfortable dropping it into this location. I run whatever relative path we're trying to link through this crate. And if there's any failures, we fall back to the original string. And with that in place, all of a sudden now all these images are appearing properly, and I won't have to do any special handling of these paths during import for a bare user. Okay, so now it's time to actually start diving into the program we're trying to write. So I want to create a subcommand where more people can add migrations in the future. I'm just going to write the bare one for now. So I set up all the plumbing that allows you to just lockbook migrate from bare. And I start getting into the actual meat and potatoes of the implementation. So the first problem we need to solve is extracting out all the tags and then through some heuristic choosing the most appropriate tag for each document. The tags allow documents to end up in multiple locations, which is fundamentally not possible inside Lockbook. We could duplicate the files themselves, but after discussing with the person I'm writing this for, we both agreed that the simplest thing would probably be to select the longest or the most specific tag and just use that as a heuristic for now. And we can add other strategies and heuristics in the future or tweak this if it becomes necessary once the person actually tries it. Once I'm happy with how tags are being interpreted as locations within Lockbook, I focus on making the output as usable as possible. I want the person who's using this migration script to have a pretty readable log file that they can look through and see of all the locations this document could have ended up, this is the one we chose. So if any documents need to be placed somewhere else, they can do that. We wrap that up and then we head over to the Linux and Windows app. I want to experiment with hiding extensions by default. This is a pretty commonly requested feature. And going along with that, I want to upgrade the quality of icons we use. Currently, we use the Google Material icons. We use the outline variant, but in my Rice, I use the Nerd Font icon pack, and I really like the way the Markdown and other icons look, so I want to make those the default, especially if I'm getting rid of the .md extension everywhere. I grab some time with whoever's around on Discord and I walk them through the changes. I see if they agree that, the expanded selection that Nerd Fonts gives us is something we want, and switching away from the outline variants is more readable and would make our app better. They think it's worth a shot, so I drop it in, and unfortunately all the identifiers that the font uses have changed, even though Nerd Fonts is a superset of the material design fonts. So I went through and I updated all the remaining descriptors and made sure that all the new icons were looking nice. When I was satisfied, I merged the result to master and allowed a round of feedback to happen from our Discord community. The community found 3 problems. The first one was that file tree icons didn't take up the same amount of space and they didn't make things like text line up nicely vertically. The hover indicator for the Markdown toolbar seemed to not be aligned center. And then finally, it seemed like the document icons looked like they were grabbing a lot more attention than the folder icons. And so I went through, I centered everything properly, updated the sizes of the Markdown toolbar icons, and then reduced the visual importance of the document icons. All right, now we get to some of the fun stuff. So our existing PDF implementation has a few problems. We use the PDF implementation that comes from the Google Chrome team. It's called PDFium. It's a C++ library, and the way we distribute it is, depending on the platform, we'll either statically link or dynamically link the binary we get from the Google team. This complicates our build process and makes it hard for us to build our app for certain platforms. And then our initial PDF implementation itself is missing some key features. For example, when you zoom in, the text gets a little blurry. All the pages are rendered at once, so it's very challenging to see very large PDF documents. And then we're missing some zoom controls around fitting to the width or fitting to the height. So I'm aiming to address all these things in this second pass implementation that I'm going to do. All of this is inspired by one of the community members sharing Hyro, a pure Rust implementation of PDF rendering. We've tried a few pure Rust implementations and sort of came to the conclusions that they weren't mature enough. But as a first step, I tested some of my most challenging PDFs in Hyro's online PDF tester. I asked the community to do the same, and I was really pleased with the results. It seemed really fast, and the PDF seemed accurate. Hyro itself was pretty easy to use. It wasn't that long before the old code was generating PDFs using Hyro instead of PDFium. What ended up taking up most of my time was actually deeply understanding eGUI's scroll area. I wanted this to only render the parts of the screen that were visible so that I could show limitless size documents. And so the first challenge was just negotiating between eGUI's coordinate space and the scroll area's coordinate space and making sure everything was getting laid out in the correct location. Once that was under control, the next several hours were spent worrying about problems of scale. Every time we rescale, the coordinate space changes dramatically in size, and eGUI isn't aware that this is happening. And so we need to do some math to calculate how to update that scroll area so that the user can zoom using control, scroll wheel, or trackpad gestures, and it'll work intuitively. The document won't be bouncing around like crazy. Once we have these abstractions in place, we can add fit to width, fit to height buttons. We can map some of these controls to keyboard shortcuts and the trackpad, and we can really get a feel of what this new PDF experience is going to be like. Once I was happy with how this felt on my computer, I tested it with a whole round of new PDFs, and then I tested it on some other devices. On my iPad, I discovered we weren't handling high-density displays correctly. There's a pixels per point that we need to take into account when asking this library to render, but once that's in place, it's looking sharp and it feels good across a variety of devices. I take the rest of the time to document this feature and write a high-quality PR description, taking stock of all the issues that we're closing related to PDFs, and then this gets queued for release. Before we release, we generally do a round of QA across a bunch of devices. This time I'm testing on my iPad, and I'm monitoring within Xcode to see what the energy impact is, specifically of PDFs, specifically of very large PDFs, but I'll generally do this with very large markdown documents or very large canvases, just so I can see to make sure that there are no energy consumption regressions or memory usage regressions. Lockbook's deployment operations are pretty involved. Our app isn't just a website that we can deploy whenever. We have a dedicated desktop app for each platform. We have a dedicated mobile app for each mobile platform. We're shipping CLIs. We're shipping libraries. We're shipping them to the app stores, package managers, different Linux distros, even GitHub releases. This used to all happen through a bunch of scripts and make files, but eventually this all evolved into a single cohesive dev tool that we call lbdev. It's the same tool that powers interesting things we do in local dev, like building a piece of Rust code and including it with our iOS app. It's the same code that powers our continuous integration. And here you're seeing me use the releaser subcommand. So if you want to check out the software end of that, check out the lbdev package. Here you're seeing me run lbdev on 3 VMs for the 3 major operating systems. We use Windows, Ubuntu, and macOS to release Lockbook to all the places that it ends up on the internet. Now that these scripts are becoming more stable, I'd like to move this into more of a continuous delivery pipeline that would automatically deploy based on various GitHub actions that we might perform, but that's a story for another day. Once the deployment automation is complete, Lockbook 25.11.11 is fully released, which also concludes this video. I hope you found that interesting. Thank you for watching, and I'll see you in the next video.